Hello, everyone. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to do a little bit of house cleaning. Can you please raise your hand using the hand icon located in the control panel to let me know if you can hear me? Okay, I see hands. Yep. Okay, great. Thank you, everyone. That's very helpful. Next, during this webinar, you'll be on mute. Should you have any questions during the discussion, please enter them in the question field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible, and those that we don't get to will be addressed in a follow-up blog post on Percona's MySQL performance blog. In addition, a recording of this webinar will be made, and I will send a link to that recording as well as a link to the slides within 48 hours. So with that said, I'd like to thank you for attending today's webinar, MySQL Security, Armoring Your Dolphin, presented by Percona Senior Consultant Ernie Surata. And with that said, I'd like to turn the floor over to Ernie. Ernie, you have the floor.
All right, thank you, and thank everyone for coming today. Just a brief note in the title, if you're not familiar with the MySQL mascot, it's a dolphin, hence the subtitle, Armoring Your Dolphin. Go ahead and get started. Things that we're going to cover today, just a brief little bit about myself. Security is a state of mind. What you want to think about from a high-level perspective when you're thinking about security. Then we're going to move on to things that are not specific to MySQL, the OS, the network, all those things that are still important but maybe aren't necessarily MySQL specific. We'll discuss some application design tips, ways of avoiding common security flaws in your application. Then don't forget the Meatware, which is us. Sometimes the weakest link in a security policy is the people that are implementing it. You may have heard of social engineering. You've got disgruntled employees, things of that sort, something to keep in mind. And once we've taken a look at all of that, then we'll look at MySQL specific items, how to run MySQL securely, from configuration to ways of running replication and things along that line. And then finally we'll look at what's new in 5.6. 5.6 has been out for a while now, and there have been all sorts of developments with NODB, performance, and scalability, but what have they done in the security arena? And as it turns out, they've actually done a surprising amount. So a little bit about me. I've been with Percona since April of 2012. My background is primarily mathematics and political science, but I've been doing IT for almost 20 years now. And as it relates to security, I'm a 10-time DEF CON attendee. If you're not familiar with DEF CON, it's an annual hacker and security conference held in Las Vegas every year. There are pictures of me that I would prefer not to talk about somewhere on the internet if you can find them. When not doing any of that, I ski. I'm a side transfer technological generalist, and I believe that specialization is for insects. I'm one of those people that is cursed or blessed with being interested in almost everything. And yes, if only it were that easy. Put a little bit of armor on your dolphin and go. So security is a state of mind. What do I mean by this? Security requires thinking about all the things that could possibly go wrong, whether it be your hardware, your network, your people. Jimmy Hoffa runs the only truly secure server in the world. And if you're not familiar with Jimmy Hoffa and why this, I say this, so he was a Teamsters union boss in the 1970s who was killed and buried somewhere. And nobody knows where, and they've never been able to find him. So that sort of goes along with the idea that the only secure server is the one that's turned off and buried in the ground. Well, in this case, it's turned off, buried in the ground, and nobody knows where it is. That's the only truly secure server that there is. Because if they want your data, they're going to find a way to get it. It's a question of time, resources, money. If someone is targeting you and they are determined to get your data, they'll find a way. And who are they? Who are the bad people? It could be anyone. It could be hackers, it could be competitors, it could be disgruntled employees or ex-employees, and it could also be the National Security Agency, although in that case they probably already have it and there's not too much you can do. So the good news here is that most of your attackers or would-be attackers are not the NSA. So we need to think about, opportunistic hackers, botnets, employees, competitors. And the first thing you want to start with is a risk analysis. What's your data worth? What's it worth to you? What's it worth to a likely attacker? And also, what's it worth to someone else? If someone's able to get into your system, get a hold of your data, and then sell it, give it away, just plaster it on the front page of Slashdot, what is that worth to you? And while you're thinking about this, certainly you want to consider the worst case scenarios, but you also really need to think about the actual likelihood of such an event. And estimating what that is kind of an art form, because you don't want to think that, oh, well, it could never happen to me, but at the same time, spending lots of time and money and resources planning for something that maybe has a 1 in 10,000 chance of happening in any given year, well, maybe that's not worth it. So you also need to think, well, in order to get where you need to be or where you think you need to be from a security perspective, that's often going to involve trade-offs. Maybe usability trade-offs, maybe some performance trade-offs, maybe cost. You're going to have to go out and spend money on something. So what are you willing to do or give up or spend to get where you need to be? It may be the case that what you want is going to involve trade-offs that either you or potentially the powers that be in your organization aren't willing to make. And that's a decision that you're going to have to deal with. So here are some general principles to think about in the whole security spectrum. These apply pretty much across the board, whether you're thinking about your hardware layer, your OS, your application, your whole stack, everything. Even when you get into policies and procedures and dealing with people. So the first one is the principle of least access, which is that you provide the user or the service with the amount of access required to do the job required and no more. So don't connect to your database's root when all you need is select, update, and delete for one database. The second one, deny by default. So this is common with firewalls, where by default everything is prohibited, and you only permit the things that you know you need. Maybe you need port 3306 or port 80 or 40, something along those lines. The opposite of that is to permit everything and then just deny selective ports, but typically there are a lot more things that you don't want or don't need, so that's not the right way to think about it. Deny everything by default and then only permit that which you need. Both of these sort of go into the next one, which is the minimization of attack surface. For this, think about all the different ways that someone could potentially get into your system. If you think about ports that are running on a server, you might have FTP, SSH, HTTP. Maybe you need those. Well, you might also have cups. Maybe you have a print server running, or maybe you have an X server running because you just happen to install one. Do you really need that? Get rid of those things, and you get rid of potential attack vectors. The fewer targets that someone has to hit, the less likely they are to hit them, which of course goes into the next one. Just don't give people easy targets. There are certain services that are just likely to be insecure. For example, X Windows. If you're running X Windows on a server to begin with, I mean, that's seriously questionable. If you're running it on a server and you're also allowing it to have network access, that's an easy target. That's just asking for trouble. Then we go into separation of concerns. Here, if you think about, let's say, a bank guard, well, you don't want the bank guard to also have access to the records. So maybe the guy is guarding the vault, and he knows where the money is, but if he also has access to the records that keep track of transactions, then you really don't have any way of knowing if some money has disappeared and the books have been cooked and no one is any the wiser. This is actually came up with recently with the whole NSA and Edward Snowden affair, where essentially he had access to sensitive data, but he also had access to the logs which reflected access to that sensitive data. So it's very easy in that situation to grab some data and then cover your tracks, and that goes into the next point. Protect your audit trail. Logs are important. You need to know if something has happened, and you need to be able to trust your logs. So putting those logs elsewhere is often a very good idea. And finally, we move on to defense in depth. This is a common security phrase that you'll hear over and over again. And the idea here is, if you think about a castle has multiple lines of defense. First, you have the soldiers out in the field, and then you have the moat and the drawbridge, and then you have various walls and hidden passages and what have you, and in the middle you have your king. So if you think about this in a computer security perspective, you don't simply want to have a firewall. It's not enough to put up a firewall and say, okay, we're secure, life is good, let's go on, because the whole soft underbelly of your network is protected. It's unprotected. It's not good enough to say, oh, well, we're going to only allow key-based access on SSH, and we're not going to have a firewall at all. That's not going to work. What happens if one of those keys is compromised? Each new defensive thing that you employ might cover a hole that was missed by a different one. And then finally, this last point of formalization, this is more of a policy and personnel perspective here, that once you have an idea of what kind of security policy and framework you want to put in place, it's important to communicate it to the people that you work with. It's important that it be written down. It doesn't necessarily have to be a book. It doesn't have to be pages upon pages upon pages, but it is important that everyone in your organization understand what's expected of them, what's allowed, what's permitted, how to handle certain situations. As your organization grows, or if you need to deal with certain compliance regimes, PCI, Sarbanes-Oxley, HIPAA, this is essential. I mean, you can't get certified without this. So if we move on to the lower layers. This is everything below MySQL. We'll start with physical security. Are your servers protected? Are your servers in a place where someone can't just go in and plug in a keyboard and a mouse, plug in a monitor, and just suddenly have console access? And for a lot of folks, this isn't going to be too applicable because most people these days don't run their own data centers. Amazon and Rackspace Cloud and other services like that are becoming more and more popular. So by and large, in those cases, you essentially have to trust that they are doing these things, that they are using multi-factor authentication to determine who actually has the ability to go in the rack, pull out a server, and do something with it. And why does this matter? Because if someone has physical access to your server, it's game over. That's it. I mean, there's really, it's not that they're going to take it and walk out with it, although I guess that is possible, but booting it into single user mode, done, game over. So really the question you have to think about here is, by and large, do you trust your infrastructure provider? Do you trust that your ISP is implementing proper security measures? If you don't, then maybe it's time to start asking them questions. What kind of authentication do they use? Do they actually maintain these sorts of logs? Who has access? Start there, and if the answers that you get aren't satisfactory, it might be time to start looking to go somewhere else. If we move on to some network elements, external firewalls are always going to be better than on-box IP tables rules. And the main reason for this is because an external firewall, whether it be Cisco ASA or even just a Linux box running IP tables, it keeps the packets from ever hitting the target machine. So you don't have to worry about the machine having to do any processing or potentially running into a bug. The packets just never get there. And you could certainly use both. You could use an external firewall and IP tables on each server. That's probably overkill. But if you're concerned about your external device not being secure enough or potentially having holes, it's one way to guard against it. And the next thing is to physically isolate your traffic. If you have one machine with two network cards, one network card plugged into a public net, another one plugged into a private net, or a management net or whatever, this is much better than running everything over the same network. If you can't do a complete physical isolation, you don't have the port density, separate VLANs. It's better than nothing. And the one thing here that is absolutely important is database servers, which is really the focus of this, should never have public IPs. There's just no reason to do that. Run a NAT or firewall or VPN, but having your database server be able to be directly accessed from the internet is asking for trouble. And in the ideal world, your database server really shouldn't have any public internet access at all. And that means outgoing too, because if someone manages to get onto your server, well, and they want to steal your data, if they have outbound access, that's easy, done. But if that box has no direct path to the outside, it's much harder. And I mean, this is one of those trade-offs that I mentioned previously. When your database server doesn't have public access, sometimes it can become a real pain in the butt from a management and ease of use standpoint. You're logged into your database server and you realize, oh, hey, I need to download a package. Oh, well, you can't because you don't have access. So that's something that you definitely need to think about and decide either if you have a workaround for it or if it's not necessarily a big deal. In most cases, what I've seen is that a lot of folks allow their database servers to hit the internet. Some banks and other places that deal with really sensitive information, they don't. For them, you might be able to get in, but getting out again is going to be extremely difficult. And that's when I mentioned that egress firewalls can help mitigate exfiltration risk. Use in-flight encryption. If you need, as I mentioned, VPN. There's all kinds of ways to do VPN. SSH, for just logging in, or tunnels if you need a quick poor man's VPN. For MySQL, you can use SSL. You can do your client connections over SSL. You can do replication over SSL. If you're worried about your data being intercepted in flight in any way, there's plenty of technologies available to guard against that. And yes, you could use Tor, but you won't get a whole lot of performance. So to paraphrase Nancy Reagan, just say no to plain text. I mean, if anyone is still using Telnet or rlogin anymore, then I'm sorry, they are beyond help. Telnet is a great diagnostic tool, but it should not be used for any kind of login, not in 2013. There are encrypted protocols for virtually every common unencrypted protocol out there, so use them. FTP, got options for that. SSH can replace Telnet and rlogin. You can do all your mail over SSL, IMAP, SSL, POP, SMTP. You can get your Usenet news over SSL, and of course HTTP as well. And yes, MySQL also works with SSL. Even though there have been some attacks recently that have sort of called into question the security level of SSL, like the breach attack, which was announced about 3 weeks ago, it's still better than nothing. It's much better than nothing. So as far as the OS, Linux or some other Unix-like OS is the way to go. And Mac OS does not count here. And I'm also going to say avoid Windows unless absolutely necessary. And when is it necessary? It's either if you have some custom code that only runs on Windows, or if your system administrators and DBAs are Windows folks and you just don't have in-house Linux knowledge. In that case, it makes much more sense to harden the Windows boxes that you have than to try to put together Linux boxes that you don't know much about. And why am I sort of saying don't run Windows? It's not because of any dislike of Microsoft. It's not because I'm a Linux fanboy. It's because when you go back to the guiding principles, think about how well Windows does that. Think about how well Linux does it. Windows, by default, is going to be running a graphical user interface. It's got the option to install browsers, Firefox, Internet Explorer. I mean, those right there are giant attack vectors waiting to happen. On the Linux side, if you do a bare base minimal install of CentOS, there's just not that much there. And you don't even have a C compiler by default. So it's much easier to minimize your attack surface and to just make your target smaller with a Linux or Unix type operating system than it is with any GUI-driven OS. Now, if you take Linux and you put X on it and you start running Firefox and all those graphical tools on the Linux side, well then, I mean, you're sort of shooting yourself in the foot. Don't do that. Keeping in with the previous slide, if there's a service on the machine that you don't need, don't just turn it off. Get rid of it entirely. Compilers, as I mentioned, those are actually useful attack tools. It's not so much the case now where GCC is available for almost everything, but in previous, I'd say 10, 15 years ago, if you were on a Sunbox and there was no compiler, getting a C compiler to somehow install on there was actually fairly difficult. So if you're a would-be attacker and you have this great new exploit that's going to give you root privileges, if you have no way to compile it, well, that's going to make your life a little bit more difficult. Maybe you can go somewhere else and build it and transfer the binary back, but that's extra work. And that goes back to the idea of no easy targets. A lot of hackers and script kiddies and random people out there that interested in messing with your system, they're looking for targets of opportunity, just like a burglar. And if you can take some of that away, then maybe they'll leave you alone. If they're not specifically looking at getting to you, they might say, hey, well, this isn't worth it. I have a list of 5 other servers that are much more easy to go after. I'm going to go over there. Heavily restrict shell access, because generally if someone's able to get on your box, even if they don't have root, if they're on your box, it's pretty much game over. There's just so many different ways that someone can take a normal user account and elevate the privileges to root that if they get on your box, you've got serious problems. And as far as passwords and such on Unix machines, the old crypt and MD5 hash functions are just not cryptographically secure. In newer versions of Linux, you can use SHA-512 and do it. This is actually how you would enable SHA-512 passwords on CentOS 6. And just to backtrack a bit, someone asked about why Mac OS X doesn't count. Primarily because it's GUI based. I mean, yes, I understand that it has a BSD core and that's all fantastic, but you've stuck that GUI on there, you've got that browser on there. I'm sorry, but I just do not believe that graphical user interfaces have any place on a server. So if we move back forward, just say yes to SELinux. And I imagine that probably some of you are groaning and wondering, why would someone ever say this? SELinux is a headache for a lot of people because they go to run something that doesn't work and they don't understand why. Permissions look good, user ownership looks good, but it just doesn't run. And oftentimes, at least with a CentOS or a RHEL system, the solution is turn off SELinux. Well, I say don't do that. Leave SELinux on and learn to make it work for you. And sure, there's going to be a performance hit, but it's not that large. And if you're pushing your system so hard that that little bit matters, then you have other things to worry about. This is about keeping your system secure from threats that you know about and also from threats that you don't. So one good thing is that if you do just a plain RPM install of MySQL, Percona server, and I imagine probably also MariaDB, they work with SELinux just out of the box. They just work. But that's only if you like the defaults. If you want your data to be in varlib MySQL, port 3306, and you want it to run as a MySQL user. If you're good with all of that, works great, no problems. But if you want to move things around, then you have to do a little bit of work. And to do it, it's mostly about security context. There's a list of the available security contexts and the types of files that they apply to. And there's also a couple of SELinux booleans which, as far as I know, don't actually seem to do anything. At least in some testing that was doing, these are both set to off, and you would think that, oh, well, this means that we don't allow any users to connect to MySQL. Well, that's actually not the case. This is set off, and you can connect to MySQL just fine. And then ports that are managed by SELinux. So you've got the MySQL D port type. You've got 1186, which I believe is an NDB port, 3306, which is pretty standard. Not sure about these dynamic ports at the upper end there. And then 2273, I'm also not sure about that one. But here you can see the ports that are controlled by SELinux. So if you want to have MySQL listen on a different port, well, that's actually pretty easy. SEManage, port, what kind of port it is and what port number is. But what's interesting about this is that, at least on CentOS 6.4, and I'm not sure if this is the case with earlier versions, any port that's not in Except for Services can be used without needing to do that. Why? I'm not sure. There might be some Heisenbergish type activity here. This was something I was messing around with yesterday, and it was kind of surprising. But that was something that I did. Maybe a bug, not sure. But when in doubt, the SEManage command will allow MySQL to listen on an alternative port. So you want to move your data directory to somewhere else? That's easy as well. You just change the context and you make it a MySQL DB type to that directory. But the one that's interesting is if you wanted to use /home/MySQL. The above command doesn't actually work because of SELinux restrictions on /home. So if you wanted to do it that way, then you actually need to use SEManage again and add a path descriptor for that type. And if you're going to start doing this, it's actually better to do it with SEManage instead of simply because at some point in the future, if your system gets relabeled, then the chcon changes won't persist. They do persist on reboot, but they don't persist on any sort of SELinux relabeling. So when in doubt, use the SEManage tools. So if you're going to try to do complicated configuration with SELinux, whether it be MySQL or otherwise, it's not easy. It's not quick. It is worth learning. Simple changes, however, they are easy to make. You just need to know how to do them. And the big thing with SELinux is that it can protect you against things that haven't been discovered yet. It can protect you against types of threats that you don't even know exist yet. So this YouTube segment actually shows using a MySQL UDF to basically get shell access. And what SELinux is designed to do is to restrict access to certain system resources. So if SELinux is saying, well, MySQL cannot do X, or it cannot write to a file in directory Y, then your malicious UDF is probably not going to work. So I say just say yes to SELinux. You'll be happy you did. So if we kind of continue back on the lower layers, finally, keep up to date with security advisories, patches to your OS, to system software, some URLs that definitely contain some good information. If you're using SSH key-based authentication, it's better than password auth, but protect your keys. And this last one here is, it's one of those trade-offs. Some people like to be able to SSH directly in as root. Well, that's convenient. That's nice. It's great for management, but it's really risky. If someone gets your key or gets onto whatever account you're using, then they've got the keys to the kingdom. So move on to the application side. First thing is you want to fail securely. So what that means is that if you're doing some kind of authorization processing and you hit an exception, maybe your network drops out or your database throws an error or whatever, that should be treated as if whatever information came in was invalid. So the operation, it should be as if the person entered an invalid password. Don't give away information that, oh, well, the user wasn't there or password invalid. So think about this from the minimization of attack surface as well. So, if we look at the examples, sometimes, if you go to a website and you log in or you mistype your password, it might say, well, you've entered invalid credentials. But what happens if you mistype your username? Does it also say you've entered invalid credentials, or does it say user not found? If it says user not found, well, now you see that website has just told you that there's now a way to do a dictionary attack and find out who are valid users. Once you have valid users, you can try guessing passwords. And then, as I said, if you can't actually do your authentication or your authorization, assume that it failed. Don't grant some sort of guest access or normal user access by default. And I mentioned this one earlier, don't connect to the database as root. Every named user accounts. Every application should have its own account with only the privileges it needs to run. And this is the principle of least access. And this is true whether it be for your application or your sysadmins or your database users, maybe over in accounting. Aside from being a good security practice, this also gives you some ammunition to go back and say, hey, hey Joe, why have you been running this query that's been running for the last 4 hours and killing the rest of the database performance? You know who's responsible. If it's malicious, you can take the appropriate action. And if it's not malicious, you can go educate people and explain to them why it is that doing a select on 10 tables with a million rows each and no index is a bad idea. Here, encryption. Don't store your sensitive data in plain text. What is sensitive data? By and large, that depends on your organization. Certainly, there's some things that are going to be sensitive regardless, credit card numbers, personally identifiable information, health records, things of that sort. That stuff is sensitive regardless. Beyond that, it really depends. I mean, you might have trade secrets that are stored in your database that might not mean anything to me, but are certainly sensitive in your industry. Don't store that in plain text. MySQL has functions for encryption. It has functions for hashing. Or you can do it in your application and just write blobs out to the database. Along the same lines, don't send sensitive data in plain text. And this could be whether it's internal to your network, or it could be if you're communicating with your end users. How many times have you gone to a website and said, oh, well, I've forgotten my password, and the email that you get back has your password in it? Well, I mean, they violated rule number 1 and they violated rule number 2 because anybody that gets a hold of that email has your password. And it's really not that much better to send someone a temporary password because it's still in plain text. It's much better if you can just give someone a link that sends them to your website and they can change their password there. This is probably the biggest application design issue, which is always validate and sanitize user input. So, like I said, always validate and sanitize user input. If you don't do this, then best case scenario, you get some garbage data. Maybe you get data that just doesn't make sense, or you get characters where you should have had numbers, or vice versa. But at worst, you've opened yourself up for all sorts of problems. You could end up with SQL injections. You could have actual SQL code in your database. You could have cross-site request forgeries, cross-site scripting attacks. Maybe someone is going to actually fill out a field or a form on your website, and in some text box they're going to put in some JavaScript or some carefully obfuscated HTML or some combination of both, which if you aren't validating that or trying to sanitize it somehow, might go straight into your database. And if it gets, let's say, displayed on that user's profile page by someone else who happens to be looking at that user's profile, well, they might have just run a whole bunch of scripts that transferred their cookie information or caused them to click on something that they didn't know about. You just don't know. And it's important to not use some overly simplistic filter, just looking for, say, greater than and less than signs, because you can miss creative ways of encoding these things. Beware of dynamic SQL. I mean, this is sort of in some ways, this is web development 101. Building up a query string using input that's been taken directly from the user and then just running it is a recipe for problems. So if we look at this query that we have, select star from items where owner equals single quote username, which came from the user presumably, and item name equals item name, which again came from the user, and that this is some random language, sort of pseudo Perl, and then we just run that. Okay, well, I mean, if the user is nice and just enters standard names, that'll run fine. But suppose that we have someone that's probing the system. They're trying different things. They put in a normal username, then they put in this funky stuff for the item, and then when that gets all translated, it turns into select star from items where owner equals black hat, okay, and item name equals name, that's okay, or A equals A. Well, semantically, that's equivalent to select star from items. So that's a fairly innocuous example because in this case, they're just retrieving data. But let's suppose that your application is connecting this root. Well, now they can sort of manipulate these things to potentially delete data or modify data, drop tables, all sorts of unpleasant stuff. So there's much better ways to do this. Instead of what we had on the previous slide, just use a parameterized statement and bind variables. So this is actual Perl. Select star from items where owner equals question mark, item name equals question mark. We prepare it, we execute it with those two bind variables, problem solved. Stored procedures, I have a love-hate relationship with stored procedures in general, but from a security standpoint, if they're parameterized, then that can be another way to prevent unnecessary stuff or unwanted stuff from hitting your database. If you're expecting an int and someone passes in, quote, A equals A, it's simply not going to work. And then OWASP, the Open Web Application something project, probably security project, I believe. There is tons of good stuff here. I mean, the amount of stuff on this website, that alone could cover multiple presentations. So I suggest taking a look at it. You'll probably learn a lot of stuff. I certainly. And don't forget the Meatware. That's us. The rogue admins, disgruntled employees, this can be your worst nightmare. They already know how your systems work. If you're firing someone or if someone's leaving, terminate their access immediately. If you're hiring new people, maybe you don't give them access to critical systems right away. And again, if you follow the guiding principles, don't give all the access to one person. This might not be feasible in smaller organizations, but in larger organizations, do you really want one super admin that has control over everything? I mean, we've seen all sorts of stories in the news. There was a network administrator for the city of San Francisco whose name I don't recall that was sort of a super admin, and he caused all sorts of issues for the city and ended up in jail. Multi-factor authentication. Another way to do this is sort of the two-man rule. It's like you're launching a nuclear missile. It's not enough for one person to enter a password. You need two people with two passwords to do certain critical things. And then this last one here is just really sort of my opinion. Personally, I think background checks and credit checks are security theater. Someone can pass a background check and be a fine employee for years, and then they get disgruntled and stuff happens. People that have bad credit, good credit, it really doesn't matter. That's not going to tell you if they're going to be a security risk. If what you're going to probably find, in a lot of cases is, as you work with people, I think, or as you interview them, generally you'll get a feel for whether or not you think they're trustworthy. You might be wrong, you might be right, and probably in 99% of the case, you'll never really need to find out because nothing will happen. But relying on these checks that take a look at scores and nebulous items, I don't know if it's really that useful. What I do think is useful is having formal written policies to explain to people what the limitations are, what the requirements are, what's expected of them. And so finally, what you've probably all been waiting for, how does all this work with MySQL? So all of the standard system network security rules that we've already covered apply to a MySQL server. Named user accounts with least privilege. Don't connect as root. Don't connect as some named user that has grant all with grant option. If you have 5 people in your organization that need database access, create 5 user accounts. Yes, it's additional management overhead, but it's worth it in the long run. This next one, don't allow root to go passwordless. I mean, this is actually really common. I see this all the time with audits. Log in to start collecting information. Oh, well, what's the MySQL root password? Oh, there isn't one. You have sudo, you have root access, you can just log in. Easy for management, it's convenient for us for doing audits, but it's not really very secure. There is the MySQL secure installation script that comes with the MySQL install. Run it. You know, it'll make you set a root password. It'll get rid of the anonymous user. And then finally, if you have a server with multiple network interfaces, bind MySQL only to the one you need. Now, if you have multiple network interfaces and you need to bind to 2, unfortunately you can't. It's either 1, none, or all. But if there's only one that you need, don't bind to the other one. If you don't need network access at all for your MySQL server, skip it. If you're always going to be connecting over localhost, there's no reason to have MySQL listening on the network at all. Old passwords. This is 4.1 and earlier. That algorithm is not secure. Don't use it. Don't create users with passwords specified like that. Go to another machine somewhere and get the password hash. Because pre-5.6, if you do create user foo at bar identified by BAS, well, that's going to end up in your MySQL history. It's going to end up in your logs. If somebody happens to see that, get on your machine, and they get your password. In the other case, well, okay, they get your password hash. That's really kind of unavoidable, but they can't reverse that and get your actual password. Go back, again, encrypt sensitive data wherever you need to do it. One thing to keep in mind here is if your app servers are separate from your database servers and you are encrypting at the application layer, then you've essentially created 2 separate targets. And that's actually can be a good thing because then if the attacker needs to get your data, they have to break into both. Don't forget about your backups. If you're taking backups of all this sensitive data and you're pushing them somewhere, well, A, make sure that they are encrypted to whatever level of security you need. Make sure that they are hashed so that you know that they haven't been changed. But if at all possible, don't store any sensitive data. This applies probably more with credit card processing than anything else. But if you can outsource that to someone else, well, then you've also outsourced the liability. They have to deal with being PCI Act compliant, and if they get hacked, it's their problem. It's not. I mean, it's still going to come back on you to some degree, but by and large, if some global payment processor gets hacked, then it's not going to be users of website XYZ that are going to come back to XYZ and say, oh, well, hey, what's the deal? They're going to be going to the payment processor and say, hey, give us our money back. What are you doing for us? If you don't need to deal with that headache, then don't. And then, full disk encryption is cool for laptops if your laptop gets stolen, but I really question what kind of utility it has in the server space. You're really going to go down to the data center and type in passwords every time you reboot a box. SSL. So if SSL can be problematic with MySQL if you have different versions of MySQL for your master, your slave, or your client. Oracle, they use SSL library called YaSSL, and older versions of the Percona server use that as well, and our newer versions use OpenSSL. So we've had some reports of software built with one having issues connecting with the software that's built with another one, and each situation is probably going to be different depending on what you have installed and what you're trying to connect to. However, if you're running recent 5.5, 5.6, sometimes a quick solution is install the old OpenSSL compatibility package. A couple of links to the 5.5 docs that explains this in more detail. And now just do a quick and dirty SSL replication. So create your own certificate authority, create a server key signing request, and then sign it. There's a link here that has some more details. Put those files on your master, put those files on your slave, add those parameters to my.cnf, bounce MySQL, and then this last one here, we're going to create a user that has no password, but is requiring a valid SSL certificate. If you want a password, you can put a password in, no big deal, but this is one way to do replication with SSL and certificates and not have to specify a password if you have password rotation policies in your organization. Once you have that set up, run the appropriate change master, start the slave, and you're done. It's actually not that complicated. Where you can run into issues is if your certificates were created with different CAs, or if you've specified different kinds of restrictions. You can restrict SSL connections so that they just use SSL. You can restrict them, as we did in this one, that they use a valid certificate. You can also say that you want a specific certificate or even a specific CA. This all depends on what you need for your requirements. And finally, there's the PAM authentication plugin. This is available in MySQL 5.5.16 if you buy a commercial package, and Percona also has a compatible open source version. And this can be a good way if you have a lot of users that you can set up role accounts, essentially, proxy users, and say that users Joe, Jack, John, and Jill all have developer, and users Bob, Tim, Ernie, and Karen all have DBA, and then you can specify what those are. So if you have a lot of users you need to track or you need to manage, these can be worthwhile things to take a look at. So 5.6, what's new? Actually, a lot of things. The first one that you might run into if you have user accounts that use the old 4.1 and earlier password authentication or password hashing algorithm is those users will not be able to connect to a 5.6 server by default. You can turn this off if you need to. You can set skip secure auth in your my.cnf, but really you should change these passwords. You just update them to use the new password hash algorithm. Next thing is if you're doing an RPM install on a fresh box, it's going to actually, instead of setting up an empty root password, it's going to create a random one and not let you do anything until you change it with the set password command. So essentially your password's going to be expired and you'll have to log in and change it. So your initial password is stored in mysql.secret or .mysql_secret, and here's a blog post from Peter Zaitsev that covers that in a little bit more detail. If you're not doing an RPM install, you can use the MySQL install DB command that everyone's probably familiar with and just pass it the -- random password flag. It'll do the same thing. These next two are actually pretty interesting. So in 5.5 and earlier, I mentioned that using a plain text password in a create user command is not a good idea. That actually isn't an issue anymore with 5.6 because anything involving passwords they're not logged to the MySQL history, and that actually includes change master, which is sort of inconvenient, but kind of nice from a security standpoint. And the passwords don't appear in plain text in your bin logs, your slow logs, so that's actually pretty cool. You can use SHA-256 for hashing, but that it's actually not quite as easy as just setting that. If you set that, you can create users with SHA-256 passwords, no problem. But then if you actually want to connect as one of them, you either need to do it over SSL or have RSA encryption of the plain text password. So there's actually quite a few setup steps involved if you want to do this. And there's a link to the documentation if you're interested in checking that out. Then they've added password quality validation checking. This can check for sort of some standard things, length of password, do you have sufficient variance in your password, numbers, special characters, capitalization. You can also match proposed password against a dictionary file. So if you want to ensure that nobody uses foobar as their password or any common passwords that you expect to be problematic, you can specify a word list and then set this up so that it gets checked when someone goes to change their password. note that if you're doing a set password and you're supplying the hash, then obviously that it doesn't work because you can't reverse the hash into a regular password. And this last one is really sort of I think a very, very small improvement. In MySQL 5.6 can store its replication credentials in a table rather than just a plain text master.info file. They're kind of touting this as a security improvement, but it really isn't, because if you're running NODB file per table, which I'd say probably 90% of people do, how hard is it to retrieve one row out of a one-row table? Just run strings on it. It's small improvement, sure. It makes things a little bit more difficult to someone that doesn't know what they're looking for, but by and large, I mean, it's nice. It's nicer for crash-safe replication than it really is for security. Some parting shots. Security is really its mindset, its process. You can't get to a certain point and say, okay, we're secure now. Well, it might be secure against the threats from today, but what about the new things that are going to be discovered tomorrow? You always need to be thinking about who's trying to get my data, what are they likely to do, and what steps have I taken to kind of prevent that from happening. But at the same time, don't go overboard. Like, the NSA is probably not after you, and if they are, then I'm afraid I can't do much for you. So it's really about risk analysis. What do you have? How valuable is it? What do you think you're going to need to do? And what are you willing to spend to protect it? And just like a link in a chain, system security is only as good as its most insecure part. And that actually, in a lot of cases, that's us. That's people that are vulnerable to social engineering. So trust no one, Agent Mulder. If you take anything away from this, aside from use SELinux, I will consider this a successful presentation if just one of you switches SELinux to enforcing. But MySQL can be secured reasonably well. You just need to follow good practices at every level of the stack. Make use of all the tools available, and hopefully you won't be the next company on the news with a data breach. So with that, I'd like to open it up for questions.
Thank you, Ernie. And we have lots and lots of questions, so we'll take as many as we can. And those that are not answered on this discussion, Ernie will do a follow-up blog post on MySQL Performance blog. So with that said, let me start asking the questions, Ernie. All right, so can you recommend tools for management monitoring of access activity logs?
So is that MySQL specific? If so, then there's not that much out there that I'm aware of. I mean, there is an audit plugin, which is a commercial tool that you can get if you buy a license from Oracle. How good is it? I'm not really sure. If you're thinking about overall system IDS and log monitoring, I mean, then you can start to look at things like Snort. Snort is a good IDS. Splunk isn't really an IDS, but it's a good way to process logs and to, if you know kind of what you're looking for. Your application itself should have some logging facilities in it, whether that be logging facilities that check for certain IPs or check for certain kind of behaviors, and they log failed access different from suspected hacks. I mean, there's also simple things like even something like fail to ban, which will scan your logs and look for repeated SSH connections from a specific host, and then IP tables block that host for a while. So it's sort of a wide open question, but I mean, there's a lot of different ways you can take that.
Okay, next question. Question regarding server isolation. What about database servers installed on the same system as the web server, maybe due to cost? Is there a good way to protect such installations?
If you have to do that, then your best approach would be to probably look into something like, we assume Linux here, something like LXC Linux containers. I hesitate to say virtualization because it's not virtualization in the same way that you think of KVM and Xan VMware. It's almost more of namespace management. Everything runs the same kernel, but there's installation between the containers. Equivalent would be something like OpenVZ or Solaris Zones. They're all on the same hardware. You could run one container that has your database instance and then another one that has your web stuff, and those containers are essentially isolated from each other. As far as I'm aware, there haven't been any publicized container jumping attacks. They might exist, but there's nothing that's well known and floating around out there in the wild. So that would probably be your best approach.
Okay, next question. Can enabling strict mode potentially help sanitize user input?
To a certain degree it can, but that's only going to really protect against invalid dates. If you're trying to put a bogus date into a date field, or if you're maybe trying to write too much data, strict mode, if you try to write 20 characters into a 10-character varchar, it will return an error as opposed to just truncating. But strict mode isn't going to look for weird SQL injection or funky HTML entities that need to be decoded. So I would say that the protection you get from that is certainly worth doing, but it's fairly minimal.
Okay. One other thing I've done is create views and give specific users permission on specific views, not actual data. What are your thoughts on that?
Depends on how you're creating the views. This is the same thing with stored routines. If you create the view with SQL security mode definer, then they essentially have your privileges. So you need to actually use the SQL security invoker to actually have some limitations there. But generally, views are a good approach for limiting access. They're also a good way to encapsulate data so that your application doesn't necessarily need to change if you've started adding columns. One thing to keep in mind, though, is that when you start doing potentially complex joins between one view and another, then your performance can start to suffer. So it's a good way to get, maybe retrieve a subset of columns from a given row by primary key, because you don't want to display other things or make those available to the application. But if you're trying to use views to create sort of mini tables that you're then going to join to other tables, you're probably going to run into performance issues. So that's where I'd start to question whether the security benefit is outweighing the performance hit.
Okay, any specific concerns with RDS in MySQL?
Well, with RDS, essentially you have to trust Amazon. This is the same thing with anything else that's running in Amazon. Amazon has been successfully audited as a PCI level 1, I believe, compliant service provider. So I'm sure that they are probably following good practices. At least I'd like to hope so. So for RDS, you've set up your security groups properly so that, that's essentially your external firewall. I really wouldn't have any concerns about RDS that would be specific to them. And in some ways, RDS might be a little bit more secure because access to the underlying box is locked down. It's a pain for troubleshooting. It's a pain for us doing audits and things of that sort. But from a security standpoint, if access to that underlying physical virtual box is restricted, and the only people that can actually get on it are essentially the Amazon engineers, then that's actually, from a security standpoint, that's actually pretty good.
Okay, and we have time for one more question, and that is, does SELinux work on Ubuntu?
Um, I'm not sure. I know Ubuntu has its own equivalent of SELinux, and that's something called AppArmor. Um, the idea behind both of them are the same. They're essentially security frameworks that provide fine-grained access control. So, if you're running Ubuntu and potentially also Debian, but I think it maybe just Ubuntu, take a look at AppArmor, AppArmor. That's going to be on recent versions of Ubuntu, and that would be your SELinux equivalent.
Okay, well, thank you, Ernie, so much for today's webinar. We're getting lots of positive feedback in our comments. For everybody who is interested, I will be sending out a link to both the recording of this webinar and the slides within the next 24 hours. And please check out our website because we have quite a robust webinar program in the next few months with lots of interesting topics, including running MySQL 5.6 on Amazon RDS for those that are interested. That's actually next week. So again, thank you so much, Ernie and audience, and we hope to see you again in the near future. Everyone have a wonderful day or evening, depending on where you are. Thank you again.